Welcome children. Now we are going to discuss about next unit work. Before going to discuss about this unit, we want to go through the unit which we discussed in our previous class, that is gravitation. From that we got some relation. You can remember it, the force between two objects anywhere in the universe, that is F is equal to G m by d square, the relation. Then from this we also find out force of gravity, F is equal to mg. It is also equal to weight of the object. Then free fall, acceleration due to gravity, that is g is equal to gm by r square. Then for a body falling freely, its acceleration is uniform. So we can use the relation V is equal to U plus AT and S equal to UT plus half AT square, and V square is equal to U square plus 2AS. These equations are also applicable for a body which is falling freely because their acceleration is uniform. These are the equations for uniformly accelerated motion. That is V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. These equations, when we replace this A with G, that is acceleration due to gravity, we will get the relation V is equal to U plus GT, S is equal to UT plus half GT square, and V square is equal to U square plus 2GS. Before going to this unit, work, energy and power, we want to solve one more problem from the unit gravitation. That is question number 18th one. See, the question is here given. A ball thrown up vertically returns to the thrower after 6 seconds. A ball thrown up vertically returns to the thrower after 6 seconds. Find A, the velocity with which it is thrown up. That means we want to find out A, the velocity with which it is thrown up, that is A. B, the maximum height it reaches, that means how much is the maximum height it reaches. Then C, its position after 4 seconds, that is C, its position we want to find out after 4 seconds. These are the things we want to find out for this problem. First of all, the ball is thrown vertically upwards and it returns to the thrower after 6 seconds. That means to travel from here to top, it takes 3 seconds. Then again to returns here, it takes 3 seconds again. So, when it reaches maximum height, the time taken is 3 seconds. So, here t is equal to 3 seconds. And when it reaches at the topmost point, that means at this point, its final velocity v is equal to 0. Final velocity v is equal to 0, and initial velocity is here given. How much that is initial velocity that we want to find out. Here we want to find out initial velocity. But acceleration g is given. How much we know? That means when the body is thrown upwards, acceleration is minus, and we can take it as a minus 9.8 meter per second square. So from the relation v is equal to u plus a t. See, v is 0, u is equal to how much that we don't know, plus a. It is minus 9.8 into t. T is 3. Now see, we can bring these two here. This minus quantity to this side and it will become plus. Then what will remain here? Here u will remain. Then 3 into 9.8, how much it will be? That means 9.8 into 3. 3 times 8, 24, balance 2, 3 times 9, 27, plus that 2, that is 29 point, that is 4 meter per second. This is the velocity with which that is thrown in the upward direction. The velocity with which the stone thrown upward is that is equal to how much? It is 29.4 meter per second. Can you remember how to find it? The things here given. Total time taken is 6 seconds. So half of the time it is taken to reach the topmost point. So t is equal to 3 seconds, v is equal to 0. We want to find out the relation we used here. V is equal to u plus at, and from this relation we got initial velocity is how much? How much is this one? 29.4 meter per second. Now what are the things? What are the other things we want to find out? That means the maximum height it reaches. We want to find out next the maximum height it reaches. See, we want to find out B, the maximum height it reaches. That is S is equal to u t plus half a t square. Here u is 29.4 into t, that is 3, plus half into a is minus 9.8 into t square. T square is how much? That is t is 3, so 3 square. Then how much it will be? 29.4 into 3. Then we see u t. That is 3 times 4, 12. Balance on. 3 times 9, 27 plus 1, 28. Balance 2. 3 times 2, 6. 6 plus 2, 8. Put this decimal. That is 88.2. Once again, 3 times 4, 12. Balance on. 3 times 9, 27. Plus that one, 28. Balance 2. And this 88.2 will get here. Now, this plus into this minus, it become minus. And when we divide with this 2, it will become 4.9 into 3. 4.9 into 3. How much it will be? 4.9 into 3 square. 4.9 into 3 square means 3 square is 9. 9 times 9 is 81. Balance 8. 9 3, 6 plus 8, that is 44, is on decimal, 44.1. Now from 88.2 we want to subtract 44.1. How much it will be? We can find out from this 88.4. 88.2 minus 44.1. 1, 4, 4. That is equal to, we get as 44.1 meter. This is the maximum height that the stone reaches. The maximum height at which the stone reached is 44.1 meter. Now, question number C, we want to find what is the position of the stone at the 4th second. That means after 4 seconds, where the stone that we want to find out. See, to find the position of the stone after 4 seconds, see, from here the stone starts, and after 3 seconds it reaches the height of how much? 88 point. That means the stone reaches to a height S is equal to how much? 44.1 meter. Here it is the height 44.1 meter it reaches. Now 4 seconds means again it travels 1 more second to here. Now we want to find out this position. That means we can find this in 2 ways. That means from here to here after 2 seconds then. Or from this to here, how much distance it travel. That if we subtract from this 44.1, we get the position. Now within 1 second, the stone travels to a distance S equal to U T plus. Suppose the stone is falling downwards. S is equal to U T plus half A T square. That is equal to U here 0 when it comes down. And T 1 plus half into A. That is 9.8 into 1 square. See, that is equal to, this term is no need to take again. Here 1 square is 1. That is 4.9 is coming. That is this travels to a distance of 4.9 meter. Now from this 44 point is the position at the time of 3 seconds. Then 4th second this will be here. That is from here it reaches, that is 4.9 meter less distance. So the distance or the height from here to here is how much? This 44.1 minus 4.9. How much it will be? That is 44.1 minus 4.9. We can't take 9 from 1, so we take from this. How much it will be? From this 4, if we take 1, here it will become 10 plus 1, 11, here 2. Now here is 3. From 3 we cannot take 4, so here 13. 13 minus 4, 9. Here how much is balance is 3. So it will be at a height of how much? That is equal to 39.2 meter. This will be at a height of 39.2 meter. This object is at a height of 39.2 meter. This we can find out from in another ways also. How? If we use the relation S is equal to when the stone thrown upward, we find out say it's upward acceleration, how much it is 29.8. That means 6. From that also we can get this answer. See, these are the things we want to know from this unit, gravitation. Now we are going to the next unit, work, energy and power. Next unit is about work, energy and power. From that, first of all we want to know about what is actually work. When we consider living beings, or when we consider our day-to-day life, we are doing so many kinds of or different types of works. Suppose when we are writing, when we are reading, suppose we are pushing a wall, or organism is jumping. In this all cases, we consider different types of works, but in some of the cases, suppose while we are sitting in a bench or table, we are reading a book that is placed on the table. We think that we are doing work, or we are eating food, or we are laughing, or any such kind of life activities. That all we consider work in our biological terms, but in our science but in physics, that we cannot consider as a work. Suppose we discuss about different types of works that are we consider work in what is in the case of living beings, but in the case of science or in physics, some of the works that we cannot consider as work. For example, we are reading or we are writing. Here, even though we are doing certain work, but in physics that is not a work. See, some other case, suppose a person standing with a heavy load on his head. Suppose a person standing with a heavy load on his head. He becomes tired after some time. We say he did a lot of work. But in physics, it is not a work. But in physics, it is not a work. But in the case of a person climbing a tree, or a jumping from one place to another, or he climbs a tree, or he is going to next story of a building, that means by climbing the steps. In this case we consider there is work. So to consider work, there must be two quantities. In a work, there must be two quantities. One, that means we must apply a force. That means when we consider the case of work, for the work there are two quantities required. One, a force must apply. Then this force should make a displacement of the object. Which are the two terms? That means a force should apply and there is required a displacement. In the case of force and displacement. If any one of these is absent, then we cannot say their work. That means to do work in science, there are two quantities required. Which are they? One, a force. Second one, that force should make a displacement on the object. That means a force must apply on an object and that object must be displaced. Then only we can say there is a work. This work actually we can write with the relation work is equal to force into displacement. Work is equal to what? Force into displacement. Let a constant force F act on an object. Let a constant force F act on an object. And if that force makes a displacement S on that object. Suppose that object is displaced to a distance along straight line S. That is we applied a constant force F, and if that force displaced the object by S, then the work done by that force W is equal to what? F into S. F into S. From this we get the idea work is the product of force and displacement. Work is the product of force and displacement. This work is a scalar quantity. Work is a scalar quantity. That means work has only magnitude. Work has only what is a magnitude, no direction. Only with the magnitude but no direction. So work is equal to F into S. It is a scalar quantity, but it means it has got only magnitude. Now we want to find out what is actually the unit of work. We know the unit of force is Newton. Unit of force is Newton. Unit of displacement is meter. So the work is with the unit Newton meter. Newton meter. This Newton meter is also called joule. Newton meter is also called joule. So the unit of work is what is joule. Then how we can define 1 joule work here? How we can define 1 joule work here? Suppose a force of 1 Newton. Suppose a force of 1 Newton makes a displacement of 1 meter. Let me apply a force of 1 Newton. If that force makes a displacement of 1 meter, then see work W is equal to, that means force is 1 Newton and displacement is 1 meter. Then work W is equal to 1 Newton into 1 meter, that is 1 joule. So here work is how much? 1 joule. So what is actually work? Work is the product of force and displacement, and work W is equal to, or work is equal to force into displacement. Let a force of F, that means let a constant force of acts on a body, and if it make a displacement S, then work done by that force W is equal to F into S. This is a scalar quantity, and its unit is a unit of force and unit of displacement. So it is Newton meter, and it is also called joule. How we can define 1 joule work? Let a force of 1 Newton displaced 1 meter, then work W is equal to 1 Newton into 1 meter, so W is equal to 1 joule. So work become 1 joule. Now see how to define 1 joule work. Now what are the different types of work? That means is the work is only positive, or if there is work negative, see if a pebble pushed this side, pushing is a force, and it moves in this to here. So the pushing force let F, and the displacement is here. Here the force and the displacement are in the same direction. Force and displacement here are in the same direction. Hence the work is positive. So work is positive when if the force and displacement are in the same direction. If both of them take place in the same direction, then that means force be applied and displacement also in the direction of force. Then we can say the work done by that force is positive. Work done by that force is positive. And for the case of a stone thrown upwards with a force, and it reaches a height here, the displacement is applied force here. See, when we consider the upward force that we applied to throw the stone, displacement yes, here force and displacement are in the same direction. So here the work is positive. Here the work is positive. But you consider the case of gravitational force. But you consider the case of gravitational force. See, gravitational force acting in the downward. Here, gravitational force acting in the downward, but the displacement is in the upward direction. So, the work done in this case, that is work done by the gravitational force here is a negative. This means if the displacement is opposite to the direction of force, if the displacement is in the opposite direction of force, then the work is negative. So, the force which be thrown the stone upward is, and displacement that is also in the upward, then the work is positive. That means force and displacement there is in the same direction. But when we consider the case of gravitational force is in the downward and displacement in the upward. So, the work done by the gravitational force here is a negative. We can take another case. Suppose a trolley is pulling or pushing. See, the applied force and the displacement are in the same direction. Hence, the work there is positive. But you see, when the trolley is moving forward, there is a force which opposes its motion. That is friction. Which is acting opposite to the motion of the trolley. Here the friction or frictional force is acting in this direction and displacement is in this direction. Now you see, force of friction and displacement are in the opposite direction. Force of friction and displacement are in the opposite direction. So here the work done by the frictional force is negative. Work done by the frictional force is negative. So work can be positive or negative, and that you got how the force and displacement makes work positive and how the force and displacement makes work negative. Sometimes work can also become zero. Suppose an object moving in a circular path. See, here it starts from here and when it reaches to the same point, displacement is zero. So the work here is zero. No displacement. And in this case also, suppose here, stone thrown upward and it reaches here and it returns here, displacement if we take that is zero. Hence also zero. And suppose a stone tied with a string, and if it is moved pulling to this side, stone is moving this side, that means force and displacement are in the same direction. But you see, gravitational force is here. That means the gravitational force is perpendicular to the displacement. Hence, the work also zero. So, work can become positive, negative, and also can it become zero. Work can be positive, negative, or also it can become zero. Now, here are some problems given for us to solve related to work. First of these, a force of 5 Newton is acting on an object. The object is displaced through 2 meters in the direction of force. If the force acts on the object all through the displacement, the work done is how much? See, a force of 5 Newton, that is F is equal to 5 Newton. Here the force is constant. Throughout the same force is acting, so the force is constant. And it makes a displacement, there is a displacement S is equal to 2 meter. Now, we want to find out how much is the work done. See, we know work is equal to force into displacement. Here, force 5 Newton into Here force is 5 Newton into displacement how much? 2 meter. 2. So this 5 into 2 how much? 10 Newton meter. That is equal to Joule. So the work done is 10 Joule. Here the work done becomes equal to, that means 5 Newton into 2 meter, 5 Newton meter or Joule. Now another question here given. See, a force of 7 Newton acts on an object. The displacement is say 8 meter in the direction of force. Let us take that the force acts on the object through the displacement. What is work done in this case? How much force is here given? How much? A force of 7 Newton. And this force makes a displacement of how much? It is 8 meter. It is 8 meter. Let us take it that the force acts on the object through the displacement. That means through the displacement means this force is constant. We want to calculate how much is the work done by this force. We know, but here force F is equal to 7 Newton and this displacement is equal to 8 meter. Hence work W is equal to F into S, that is equal to 7 into 8, that is equal to 56 Newton meter or 56 Joule. 56 Joule is the work done. Now see another problem. A porter lifts a luggage of 15 kilogram from the ground and put it on his head 1.5 meter above the ground. Calculate the work done. Calculate the work done by him on the luggage. See, a porter lifted a luggage of 15 kg. That means the mass of the luggage is given. M is equal to 15 kg. M is equal to 15 kg and it lifts to a height of 1.5 meter above the ground. See, height h or s equal to 1.5 meter. Now we want to find out of work. That means W is equal to work W is equal to what is F into S. Work W is equal to F into S. See, F is here not given, but here F is actually what is a gravitational force. Here F is equal to gravitational force, so F is equal to we can take as mg. So this we can take as mg s or h. Instead of s we can take as h. Then m is 15, g is 9.8 into h 1.5. 15 into 9.8 into 1.5. Here 15 times 15 225 into 9.8. How much it will be? 8 times 5 40 balance 4. 8 times 2 16 plus 4 20 balance 2. 8 times 2 16 plus 2 18. 9 times 5 45. Balance 4. 9 times 2, 18. 18 plus 4, 22. Balance 2. 9 times 2, 18 plus 2, 20. How many decimal you want to give? Here on decimal and here on decimal total. How much? 2 decimal. That is equal to 220.4. This much joule is the work done. Once again, a person lifts a mass of 15 kg and to a height of 1.5 meter on his head. Work W is equal to force into displacement. But here force is gravitational force mg. So 15 into 9.80. H 1.5. We multiply 15 into 15 to 25. We can put on decimal here. Then with the 9.8, then altogether 220.40. 2 decimal is given. We can put this 0 if it is required. But that 0 has no value. So no need to write it. Okay. This is the answer for this question. Now, the questions given. Here, first one, when do we say that work is done? To say work is done, a force we must apply and it makes a displacement. That means these two quantities there for we want to say work is done, force and displacement. Then second question, write an expression for work done when a force is acting on an object in the direction of its displacement. That means write an expression for the work done when a force is acting on an object in the direction of its displacement. If the displacement is in the direction of force, then work W is equal to F into S and it is positive. That work is positive. Define on joule. Define on joule of work. That means if a force of 1 Newton, F is equal to 1 Newton, and if the displacement is equal to 1 meter, then W is equal to 1 into 1, that is equal to 1 joule. That means if a force of 1 Newton makes a displacement of 1 meter, then the work done is 1 joule. Then fourth question from page number 149. A pair of bullocks exerts a force of 140 Newton. That means force exerted, that is 140 Newton. A pair of bullocks exert a force of 140 Newton on a plough. The field being ploughed is 15 meter long. That means ploughed distance or displacement is 15 meter. Then how much work is done in ploughing the length of the field? How much is the work done? We know work is W is equal to F into S. So F is here 140 into S 50. 14 times 50. How much it will be? That means 140 into 50. 5 times 0, 5. 5 times 4, 20. Balance 2. 5 times 1, 5. This 2, 7. Once again, 5 times 0, 5, 0. 5 times 4, 20. Balance 2. And 5 times 1 is 5. Plus 2, 7. 1 times 0, 4, 1. That is how much it will be. This is the work done by the bullock. This is how much is the work done by the bullock? That is 2100 joule. Now, with these things, we discuss about work. So, what are the things you want to remember? What is actually work? Work is the product of. That means when we apply a force and if it makes a displacement, we can say there is work. Then work depends on two factors. Which are they? Which are they? Force and displacement. Work depends on two factors. Which are they? Force and displacement. When does work becomes positive? When does, if there is force and displacement are in the same direction, we can say work is positive. When does work becomes negative? If force and displacement are in the opposite direction, then we say work is negative. We want to know when does examples for positive work and also negative work. And when does work become zero? Among these, any one of the code displacement is not there, then the work is zero. And in some other case there is force and is applied in a circular motion. If the body returns to the same position, then there is no displacement, then also work is zero. Then work is positive, work is negative, and work is zero. And which is the relation used to find? Which is the relation used to find or to calculate work? Which is the relation? W is equal to F into S. And what is the unit of work? Unit of work is unit of force and unit of displacement Newton meter. Otherwise it is called joule. Then you want to remember what is actually 1 joule of work. 1 joule of is the work is the, if we apply a force of 1 Newton to a body and it made a displacement of 1 meter, then the work done is 1 joule. Okay, with this all we can conclude our class today. Thank you.